Behind me is a genuine GT XY Falcon. This car's here to have the full fit out of RRS products front to rear. It's in the factory of BJ Bonneville, one of RRS main distributors, and this car is getting the full works. So let me show you what we're doing. Here's one of the reasons why most people require an RRS suspension and steering system. When you upgrade from this type of tyre and rim to this, places a greater demand on the steering geometry, suspension response, to take full advantage of the handling that you can get from these modern wheels and tyres. So let me show you some of the things that have been upgraded on this GT that enhances from the wheels up. So firstly, we have a 3-link rear suspension, coilover, height adjustable. We have a disc brake rear, ventilated rear discs that are slotted, 6-piston calipers, using the original handbrake cable so that everything is a bolt-on. Going to the front, we have the RRS rack and pinion, RRS tie rod adjuster sleeves, RRS strut and front end, RRS brake upgrade with 6-piston calipers on the front, and large diameter ventilated and slotted rotors on the front. All of this is to take advantage of the most modern engineering standards that you can see in a car today. You'll notice some of the design features of the RRS rack and pinion system. We have urethane mounts to ensure anti-vibration and to allow for chassis racking. This is a most important feature. When a chassis racks or twists, you have to allow for compliance in here. You cannot have a rack as a stressed chassis member. It will ultimately fail. It's one of the main sort of design parameters that you have to consider with a monocoque chassis. You'll also notice our patented linear tracking device here as a third stability point for accuracy of steering. Because it is a centre steer system, we have a centre mount. Now, the important point about the centre mount is that this is a provision for adjusting bump steer. All of these vintage Falcons and Mustangs have factory bump steer, and the only way you can correct this is by changing either inner or outer tie rod end positions. And from my experience, it's better to change the inner ones. You get far more response and an overall effect of reduction of bump steer. One of the most important things to remember is that all of these vintage Falcons and Mustangs have a huge amount of factory bump steer. If you're fine-tuning this aspect, it's best to consult with RRS head office. However, there is a design feature built into the rack and pinion that allows for this. Our centre brackets that mount the inner drag link, this component here, allows different heights of inner tie rod ends. It is my personal preference to adjust those as a primary location for correcting bump steer. Now, added to that, I'll show you something else while it's here, is the RRS rack and pinion conversion pieces for the steering column. These pieces are most important to make the kit complete. It replaces a factory rag joint or a solid steering shaft. We provide all the parts to convert it, but when installing these, the most important part is to get the position of these two universals phased correctly. If you don't do that, you'll end up with a lumpy steering feel. Because this car is using modern radial tyres, it's important that all the steering geometry is correct. The Ackerman angle, the camber gain, the steering axis inclination, the bump steer, and a lot of adjustment for camber and caster. You'll notice a number of very important design features. There's a camber adjustment on the RRS strut leg. You can use the factory original camber setting, both to adjust camber or fine-tune the track of the vehicle so that the wheel spacing underneath the guards is equal. This is quite a unique feature of our product range. Again, it's important to remember that this is a monocoque chassis. So when you put a modified suspension system in, like an RRS 3-link rear end, it's very important to understand how this integrates into the chassis. You'll see a massive amount of bolts here. That's because it requires that to spread the load evenly and become part of the chassis. That way you get maximum reinforcement, You also reduce beaming and torsioning, and a perfect location to mount the torque transference through the torque arm back into the chassis. Some of the other features that I'd like to show you in the 3-link rear end is height adjustment. This can be adjusted by unbolting this mounting bracket or alternatively adjusting the shock absorber. The RRS 3-link is fitted with tubular trailing arms that has urethane joints front and rear. This gives the highest degree of accuracy, durability, and unlike a hard jointed system, gives articulation without the problems of fatigue cycling failure. So the shelf life of these units is literally double that of a rod end, which is perfectly suited for a road car or a semi-race car. Added to that, you've got additional clearance because of the offset of the arms, eliminating the rear leaf springs. That allows much wider tyres and a provision for mini tubbing. On an original leaf sprung car, the torque circuit is the tail shaft generating the twisting action through the axle housing, reacting with the road, and then back through the leaf springs, back through the chassis, back to the engine mounts. That's the torque circuit. When you install an RRS 3-link, the torque circuit is down the tail shaft, through the axle housing, reverses with the road, and then is transferred through the torque arm, back up through the chassis, closer to the engine mounts. This produces a zero axle hop and also an anti-dive characteristic. It can also have the pinion angle adjusted and fine-tuned. All of these things you should consult with your RRS dealer about if you're going to make any modifications of that sort. It's very important to remember if you're using a 5 or a 6-speed transmission to get your tail shaft pinion angle correct. Otherwise you could have tail shaft vibrations. All of these things allow for a much stiffer chassis. By eliminating the transference of torque through the chassis becomes a more responsive and solid platform, thereby in most vehicles negating the necessity for subframe connectors. Beaming and torsioning is reduced not only by the transference of torque, but also by the chassis members that we bolt in that actually reinforce the chassis. Normally, the load of the rear of the vehicle is transferred from the front spring eye to the rear spring eye. We've shortened that distance and literally halved the load in the chassis by shortening that distance, because force is a measurement of mass times distance. You reduce the distance, it's like reducing the mass. So no longer is the weight of the vehicle dependent on those components. Added to that, we've totally eliminated rear steer. Now, one of the key points of a leaf sprung rear end, and it's why most performance cars don't use them anymore, is that they rear steer. When the car rolls and one side compresses, the leaf spring on the compressed side shortens dramatically, sometimes as much as 2.5 inches. This skews the rear axle and points the car in the wrong direction and creates understeer. The evidence of this is when you look at the axle center line and where the original bump rubber is, they're completely out of whack in the resting position. It's also why there's a spring shackle on the rear to allow for the shortening and lengthening of the leaf spring, and why there's a massive amount of movement in the slip yoke in the back of the tail shaft. All of these things are reduced dramatically when you use an RRS 3-link. RRS has researched and tested numerous different methods of attaching a torque arm to a 9-inch axle housing, and we've determined that this is the best and most reliable method. It's very important to understand that there's a massive amount of end thrust created in the pinion housing from a typical 9-inch, and that's trying to force that pinion out. If you were to attach a torque arm only to that, and we tried that as well, it would cause 9-inch failure. So instead we attach it there and reinforce it like a stud girdle on a crankshaft by these extension studs that distributes the load right over the axle housing, thereby making the axle housing and the pinion center stronger because it's now a captured piece. It provides a perfect mounting location, and we've had as much as 1,500 horsepower go through these units in a reliable fashion. The RRS strut front end is designed to be oriented in the chassis in a particular way. It's important that the grease fitting on all of the RRS strut front ends points towards the middle of the radiator support panel. This guarantees that it's mounted in the correct location, providing the correct steering axis inclination. Added to that, if for some reason you do mount it round the wrong way, It's not a disaster. It won't cause a catastrophic failure. But it's important to note that it is installed correctly. And I'll show you one more thing. You'll notice in the middle of the bearing hub, there's no grease cap. That's because this is a bearing hub. The bearing hub design means that you have an increased load bearing capacity, which means that you can run bigger diameter rims and much wider tyres without any detriment. This car's had a massive upgrade. Perfect balance between the front and rear brakes. This car's going to stop on a penny.